All right, folks, we want to uncover what it means to not just have an access point, but to have an access point that is associated with a wireless LAN controller, right? What's really going on when we have these devices in our network? Well, first, the protocol that we're going to be using with our Cisco access points and wireless LAN controllers is called Capwap, all right? Control and provisioning of wireless access points used between the APs and the wireless LAN controller. Awesome. Now, don't be confused if you see references out there to LWAP, all right? The Lightweight Access Point Protocol, LWAP. LWAP is the antecedent to Capwap. LWAP developed by a company purchased by Cisco, designed for this purpose, and then was then improved upon with the Capwap protocol, which again, Cisco had a large emphasis in developing, although Capwap is an open protocol. Okay, it is not proprietary. So what's going to end up happening is you've got an access point. Now, if this access point is loaded with an autonomous image, right? If the AirOS image is the autonomous AirOS image for this access point, it's just going to function like an access point. You better log on and configure it because it's waiting for you. But if it's been loaded with a lightweight access point image, you'll usually see LAP in the name of those image files. Then on booting this access point, it's going to send out a certain type of discovery message trying to find a lightweight access point controller. So it discovers it and it joins it. It says, hey, you're my controller. Tell me what to do. The controller then will have the ability to manage this access point. I can log in as the administrator of the controller and say, okay, here's what you need. You need to have this configuration. Here's the SSID you're going to be using. Here's the security model. Turn on clean air, turn off clean air, whatever it might be. I'm going to dictate the controls to the access point, the configuration. Right? You don't do it locally, you do it here in the controller. Then I'm also going to have the ability to even push out firmware. So if I have legacy devices that were able to be discovered using LWAP, I can then upgrade them to a Capwap supporting image if that's available to push to that type of access point. Pretty cool. So once we've got that in place, then the real magic happens. So in this case, we've got, Joe, the Wi-Fi client, trying to access a business application on the far right. How does that actually happen? Well, if it was the classic autonomous model, they'd connect to an access point which is connected to a switch, and so they just go directly there. But it's not the standard model. It's the Capwap model. And so with the Capwap model, what we're going to see instead is that client is going to have local communication with that access point. In other words, CSMA, CA, it's right there. Beaconing, probe, who do I send my probe request to? I'm going to send it to that access point. But that probe request is going to be forwarded by the access point to the controller using a control plane tunnel that's being set up between the access point and the controller that is actually encrypted. Then, depending on whatever policies are defined there in the controller will say, yes, okay, I see who you are. You're allowed to log in this way. So maybe a device determines that, or the network that we're coming in from. And so we have these remote operations that are used for the initial authentication and policy determination. Additionally, over this control plane, which we use to send the configuration, send the firmware, and we use to manage these elements of access, we get negotiated, right? We get access to the network. So now that I have access to the network, which is really through the controller, I then say, well, I'd like to access this business application. I fire up my database application or my email or whatever it might be. So now the client physically contacts the access point with the request to access something on the remote network. But that request is going to go through the data plane tunnel directly to the wireless LAN controller. And it is from the wireless LAN controller that we then control whether or not we allow it to go to the business application. So guess where access control lists are managed? Here at the controller. That's what's defining it centrally. We don't have to define it out there in the wild. It's per SSID and per device and however you want to manage it. You can create the groups that make sense. And then centrally, you're able to do this. So this is essentially our distribution layer. If you're familiar with access layer and distribution layer switches, it's providing that type of functionality. And so just like in a switched environment, you work your way through the distribution layer to reach another network, we would do the same thing here. It'll gather those statistics, it provides that security. And again, we're doing that through specific ports. So the control plane communication is operating at UDP 5246. The data plane is at 5247. Again, may or may not be encrypted. LWAP, by the way, very similar to some degree in terms of how it automatically discovers controllers and gets access to the network and is a split MAC set of control. But it operates at different port numbers. Okay, so it's going to be in a much higher number port range in the 14,000s as opposed to Capwap, which is way down here at 52, 46, and 47. So slight difference there. Just if you're running a firewall and you were supporting both, because Capwap is backward compatible to LWAP, you would definitely want to make sure that you'd open those ports up correctly.